Differentiation. Okay, this is a big subject in calculus. We'll be studying two things coming up here. One is differentiation. Another important concept coming up is integration. This is not going to be a course in calculus, but from time to time we will need to be able to speak intelligently about taking your derivatives or differentiation and finding integrals or doing integration. Again, this is not a course in calculus, and it's not going to be very theoretical, but do want you to, at the very least, be aware of the concepts. Okay, so let's suppose that f is some nice function. We won't talk about what that means, but let's say it's nice and smooth. You know, maybe it even looks like, we could just draw a picture of it here, make it sort of take some shape. And it maps, say, part of the reals to part of the reals. Okay, look like that maybe. Okay, some nice smooth curve, and so the derivative of f with respect to x is defined to be this. First of all, this is the notation for it. We can thank some dead guy named Leibniz for this. The derivative of the function with respect to x. Okay, you can think of this little d as a delta, and this little d is a delta, and so it sort of says the change in f of x divided by the change in x. What is that? Change in y, or f of x, divided by the change in x? That's the rise over the run, right? Yeah, the idea here is you want to, is that the derivative seeks to find the slope of a line tangent to this curve at a point. Let's say you're interested in, you know, maybe what's going on right here at this point. We'll call it x, okay? Why the heck not? There we go. And so this value, sorry about that, better take your Dramamine, is f of x, right? Now what if I come over here to a point near it, and let's say this is x plus some small amount h, okay? Then I go up, hit the curve there. That's f of x plus h, right? So the idea is, if I could get h to be really small, then what do I have there? Then I have the rise divided by the run, which is going to be the slope of a line that runs tangent to this curve right there at that there point, right? Okay, and so that's what we mean by taking the limit as h goes to 0. Okay, there are lots of ways to define derivatives, and some derivatives are different from others and so forth, but we're going to keep it pretty simple here. We're going to consider just nice smooth functions for the time being, so it doesn't matter if we take h to be negative or positive. We're just going to say that h gets to be very small, and so you can imagine what would happen if if h got very small, then the 2 points on this curve would get very close together, and then you have this little itty bitty rise divided by this little itty bitty run. Okay, and you're getting a slope there. Okay, we'll say that a function is differentiable if its derivative sort of makes sense, or if it makes sense to take the derivative. For example, this function is differentiable all along here, right? It looks like it. You know, you could draw tangent lines, right? All at these different points. By the way, we'll come back to this again later, but look at that. Tangent lines at maximums and minimums like that are going to have a slope of 0, right? That's something you probably ought to be aware of. So it's differentiable at all these different points. But what happens if what if I happen to have a jump like this? Okay, the function takes a jump there. It doesn't really make sense now to talk about the derivative here at this point. Okay, the derivative doesn't exactly exist at that point. It sort of exists as you approach from the right, and it sort of exists as you approach from the left, but they could be two very different things. Okay, we'll say that derivatives make sense if well, or that the function is differentiable if it makes sense, or it's differentiable at points if it makes sense to attempt to find them at those points. Another kind of point where it might not make any sense is what if you looked at a function that went like this? Okay, it's not differentiable there. There's no real unique line that runs through that point, right? Okay, so it doesn't make sense to talk about the derivative there. Okay,